Good afternoon, everyone. Happy Tuesday during Modex Week. Thank you for being here. This is Hy-Tek and Fulfillment IQ panel on orchestrating the AI-driven warehouse. A very heavy topic, but a lot of interest in the industry right now, a lot of questions, as all of you are aware of. But before we get into that, let's begin with quick introductions. I'm Mansi David. I'm the VP of Product Management at Hy-Tek Intralogistics. Hy-Tek is an end-to-end automation and systems integrator. What that means is we work across the breadth of automation and software to bring the right solutions to our customers. And my role is in defining and identifying that product strategy and definition. And Ninad?
Hello, everyone. I'm Ninad Acharya. I am CEO and founder at Fulfillment IQ. Can you hear me okay? Yeah, I think so. What does Fulfillment IQ do? Real quick, we kind of sit at the intersection of strategy.
I think there is some.
Okay. So we kind of sit at the intersection of strategy, technology, and operations, providing consultative services, but we also have a venture studio in developing new products around distribution technology. So that's kind of the focus area. AI, digital twins, these are areas that we actually work on in real time at a enterprise scale, as well as we try to address the mid-market needs. How do you bring the enterprise solutions to the mid-market, make it more democratized?
Before we, again, just because this is such a heavy topic, right, Ninad, are there some definitions to cover, right? AI is a term that is used very broadly, very generically, same as digital twins, right? But they're essentially major streams of engineering and can be broken down further. So how would you characterize that?
I think the way to do justice to the industry is, first of all, to break down AI. When I think about the four walls of the warehouse, there is the first part is, what do you mean by AI? AI is your frontier models like your ChatGPT, Claudes, etc., and people use them, the chat functions. Then you have the ability to actually have a SaaS embedded solution. So your software vendor kind of provides you something that's embedded, that provides you the capability to configure the application or a solution, or to test a new feature, a function, etc., or just chatting with your own application, be it your WMS, your WCS, WES, be able to kind of figure out what's happening in there. And the third one, which I think is really critical, is that custom AI, that rooted AI that actually helps you orchestrate across the network. And I want to break that down even further, operationally speaking, four areas. One is that rules layer, right?
Yep.
The ability to kind of control and change the rules of your application. I think that's one. The second one is going to be your physical AI. So that's your machine AI. How is it your AMR fleet is talking to each other? How is it actually making inference and decision in the training side of the equation, et cetera, that goes into it? Then you kind of get down to the orchestration AI, which is how are all the pieces of your systems inside the facility orchestrating across the network itself, or within the facility itself. And I think it's really important to delineate those pieces. And then when a lot of people say, I just said that previously, oh, we are implementing AI in the warehouse. Well, there is a good chance you're just bringing in an AMR fleet inside your building, right? I mean, and when people say a lot of these things like, oh, we are working on agents, and it's like, yeah, is it at a scale that actually informs you, and do you have the agentic scale? And I feel like there is still a lot of education and catching up to do around it.
I absolutely agree, but I do want to address a topic in that, right? Because you hear this in the market. Gartner specifically specifies that 77% of executives in our industry, in warehouse automation, feel that their current operating models are unfit for AI implementation because of the amount of fragmentation in the workflows and manual touch points that are required. So that was absolutely to your point, but one thing that I want to address here is the term fragmentation, right? If it is looked upon as multiple, like this is an industry where within the four walls of one warehouse, there are going to be multi OEMs and many equipment and automation from different vendors. That fragmentation is needed, and it's a strategy, not a failure mode, right? So the solution, so there is some amount of responsibility now that ends up on the higher orchestrating layer or a platform to bring the data needed for that scaled up AI implementation from across these multiple OEMs. And going back to your point of physical AI versus operational AI, you're right. There is a lot of physical, when we use the word physical AI, what it means is like the data that is coming to us through the sensors, through robots, right? The vision systems and the navigation of the robots, that the decision making is happening in the physical world, right? So that absolutely exists. It's all around us everywhere. But how do we use those data points to then actually make operational decisions for end-to-end optimization, right? That's the scale.
I couldn't agree more, right? At the end of the day, every solution, every partner, every vendor is going to embed AI inside their application and provide the solution. Like that's pretty much a table stake at this point. But when it comes to the orchestration side, where the challenge actually resides is, well, where the challenge actually resides right now is the canonical model that's required to understand the entire layer. One thing we all have to understand is the context windows that AI has is not that large. I read it this morning, like a context window is the size of, what book was it? It was one of the book series, let's call it Lord of the Rings.
I
And
was
it's
just
like,
going to say Lord of the Rings.
300 copies of Lord of the Rings is the total number of words that it can actually hold in its context window at any given time. Well, to make operational decision in real time, what has to happen is from each vendor's perspective, first of all, data replication, that problem's been solved a while ago, right? Be it your WES vendor, be it your WCS, your WMS, you can replicate the data. Well, everyone's sitting with this big cathedral of data lake, as they call it. Well, that's not usable by AI because it's way too much. So what has to happen is the canonical has to then become more normalized. So what is a pick? What is a task across the entire process between every system has to be mapped together. And that's when AI becomes really powerful, because at that point it can infer the information much more quickly. I would say majority of the companies we work with right now are in that phase of figuring out their data strategy.
Absolutely right. Like this is what I meant when I said like that with so many OEMs within the same warehouse, the responsibility becomes of that orchestration layer. It is that kind of data modeling that would be required so that each OEM system is then talking in the same language, or at least that interpretation is happening in that same language for it to actually generate meaningful results. So perfect. So let's, if you don't mind, let's talk about something tangible.
Yeah.
Right. You've mentioned in I think one of your white papers about the emphasis that the transformation begins when AI moves beyond isolated tests. What does that mean?
What we see, I would say, there is a figure that we saw from McKinsey that was 92% of companies are working on something related to AI as a primary initiative within the company. The current adoption and maturity rate right now is less than 1%, where you could actually say the companies have been able to truly adopt the scale of AI. And so what's happening is a lot of these internal projects around AI implementations that are not seeing the light of day from a real-time implementation standpoint. W- the repeated pattern that we are seeing is that fail fast, fail forward model, the enterprise governance, you need to start becoming extremely flexible to be able to apply that, because by the time you get information security approval around a new AI model, which is launching every 3 months, by the way, at this point, uh, 3 new models have come out at this point. And so what's your training mechanism? What are you doing to actually keep incorporating the newer capabilities into the model, but be really fast about what you do? All companies have to learn this, and there is some really good vendors that are coming out with solutions within our space that are also trying to solve for this particular problem. But the challenge is, yes, we are seeing too many experiments, not enough real implementations.
So that's another excellent point, right? Like the fact about these experiments. One word of caution, my opinion, again, 2 cents, for the warehouses and the customers who are trying to look for areas to implement this, and the word POC comes to my mind, right? That is the proof of concept that you can choose any one of these areas and jump into it. But I think depending on the warehouse, identifying why to solve a problem is very important. Because of the so many different models available in the market, the problem statement will define what type of model, what type of data that you need to make that successful, right? So you focus your energy into that individual POC area, be it, even if you think about the physical AI world, right? The congestion solving problem in the warehouse, or order prioritization, or slotting, or digital twin and simulation for what if scenarios, like I want to make sure that my peak season, I am set up for the right amount of automation, right amount of people. That use case is going to define what type of data you need to normalize, which technology to work with, which specific model to work with, and even within AI, which type of engineering to implement. So working with the right partners, identifying the right business case for that POC is crucial for the customers who are looking to do this.
I think as a public service message that I want to tell everyone at this point is the cost of token has increased 5-fold
Very true.
at this point. I don't think people realize that part of it. And we are seeing this right now inside our company, where the cost concern is starting to creep in, and the model selection for what you do starts becoming hypercritical. It is, and I would say pretty much everyone, and specifically this industry itself, should be working on local models, on-prem, where you are actually containing the cost. You don't need Claude level models
True.
to be able to answer certain basic questions around, is the security from an agent that's actually firing information around security and some of these other details, right? But then you do need these larger models from a general orchestration and knowledge base standpoint. So again, my public service message is focus on the models and look at the cost. Out of control.
And use the right partners. I mean, this is an area where both the operational expertise and the technical expertise are crucial, that they come together, identify the right business case, identify the right technology, and the right solution together, because it cannot be done in isolation. Those POCs are crucial for to understanding how we scale, but identifying what results you're looking for early on and then maturing that forward together is important.
100%.
So do you want to move on to a topic of simulation and digital twins?
I love it.
What you've stated that digital twins allow teams to debug everything before investing the first CapEx dollar. You want to expand on that?
Yeah, so the first thing that I want to do, the same thing that we did on the AI side, is let's break this down, the term digital twin.
Oh, yes.
It actually does get on my nerves at times with what people think and what the reality actually happens to be. A good way to think, 3 kind of core areas: When most people think about digital twins, they think about visualization. That's not the most important part, by the way. It's the secondary part. The other two areas are digital twin, the actual word, and I'll go into the details a little bit. And then the third one, which is by far the most important, is the simulation side of the equation.
Yep.
Because visualization is more like the dashboard of your car, right? Like what you see, the information that's in real time. Digital twin is the model that takes your real-time data for your facility, your design, your MHE, your equipment, your automation, all the sensor data, everything firing at the same time, and you can actually see it, and it's more like, what can I do with this dashboard and control it? I think what's really critical is the simulation that goes underneath it. This is that model that actually allows you to say, well, what happens if I do X? And what happens if I do Y for my peak season? What changes do I need to make? What happens as far as if I was to remove a given aisle or a layer of racking, what's the impact on my overall flow? That is the simulation part that I don't think most people kind of think about. Everyone thinks about, like, I can see the visualization of my actual warehouse. And I think that clean delineation is super critical to start with. And I'm betting big on simulation over everything else.
100%. And like everything else, like this is, again, one of those technologies that is available, but it has a roadmap in reality for operations, right? So you go from that simulation and then figuring out, again, I'm going to keep harping about the use cases. You figure out what your use case is. Is your use case to figure out what my peak season throughput is going to be? Or is it that I have a major change coming in, I want to make sure that it goes through smoothly? Or is it, how many robots and humans do I have to deploy for figuring out who's doing what?
Yep.
So depending on that, the models are going to be different, and the simulation is going to be different. So choosing the platform, choosing the right, again, if you have to build the data models, right data to support that is crucial.
Also, one more public service message on the visualization side. It's expensive, by the way.
It is expensive.
We work with NVIDIA very closely on their Omniverse models, which is actually the primary engine in the industry right now that allows you to layer the simulation underneath that then creates that visualization on top, creating what people would define as digital twins. A single rack frame with basic warehouse layout will run you close to $5,000 to $6,000 a month, and that's just basic. It starts accelerating so quickly, a single DGX frame will cost you $800,000 in CapEx to just purchase. That will be out of season in 1 year because NVIDIA is going to come out with a new model that you have to kind of run to be able to get all the new fancy benefits, right? So be careful what you ask for when it comes to some of that tech. I love my PSAs, so.
No, I was going to go into, absolutely right? The toolkits that, and this is getting a little more technical, but the toolkits that are available in each of these bigger tools, like NVIDIA is one, Siemens has another one, right? Figuring out which ones to use that are more going to be effective for you, and then, again, based on what problems you're trying to solve.
I think where the industry is at right now is these simulations are building by building by building. Where we need to get to is a more bigger kind of conceptual design, let's call it software stack, that can actually solve for it all on a more repeatable basis that becomes more commercially available. And we don't see that in the industry today. Like, that's where the challenge resides. Of course, a large grocer chain can go out to a consulting company that specializes in simulation, and they can have one built for them for $1 million. But that's not affordable to someone that's running a 3PL warehouse with, 150,000 square feet with, limited capex and 8% EBITDA margin. You know what I'm saying? Yeah.
Perfect. And also, something to note is that the digital twin, the simulation digital twin, is not necessarily a decision twin. term that I just thought of. Because tying it back to the AI piece, right? Like if we are actually looking for figuring out agentic AI to take those decisions for us, right? You have the simulation done, you have the digital twin built up, all that data is feeding back to the system, right? Eating your own dog food. At what point does it become viable to start making some autonomous decisions? We will need some form of human in the loop as this technology evolves, but where is that trust?
Yeah, at this point it isn't, and it's like any technology, right? Even if you look at RPA or robotic process automation type capabilities, you can keep the prescriptive side versus the predictive side kind of separated out, right? So predictiveness, human in loop is going to be there. The prescriptive is where the automation kind of kicks in. I do believe that we are going to end up there as these models evolve and things become bigger. But at this point, where we reside is more probably in the human in loop, predictive arena. And so the simulation models, and for me, I would say the best CapEx use case for simulation is in warehouse design and not in warehouse ops, because it becomes more expensive on the ops side to maintain and control that versus you are making a $100 million CapEx decision. That simulation actually helps you make a much better decision of what your building should be. I'm not saying don't do the other side, but if I was to weigh the options, I would definitely put more weight on what do I choose from a design standpoint? How am I going to compile my warehouse? What are my options? What are my automation options? What's my rack style? Like, what am I building for? What's going to be my ROI, my output, my design, my throughputs, right? Like my variable cost per unit. All of that calculation is much better suited earlier on. But once you have that model, you can run it on the other side. I think a lot of people think about the other side first.
I see that, but I'll challenge that a little bit in saying that there is a lot of cost of implementation, especially for greenfield facilities or even brownfield, right? Major changes in hardware that, be it removal or replacement of conveyors and PLCs, those are massive costs for projects. So as we think of the design, if the implementation costs could be, impacted by the use of same simulation model, there is a lot of value in keeping that model alive and supporting it so that the engineering and implementation costs could be limited.
The only thing I'll say is what that does is you're still solving for the challenge after the facility is designed. Where I'm trying to get to is, well, if you actually start with that simulated model early, then those decisions become much easier on the other side. Or else you got a running brownfield facility where you are trying to overlay this, structure on top, which is a little harder to do because, well, are you just then trying to solve for the CapEx of that particular part of the facility while not taking a look at, because guess what you will do with simulation? You will solve for that picking problem that you have rather than looking at the entire flow and how everything kind of interconnects with it, right? And that's, again, I'm not saying don't do the other side. I'm saying start on the, if you can, you should, if you're thinking about a new facility, you should be thinking about simulation from a design standpoint early on.
I think we have rambled for a long time, but just to wrap up the conversation, I do want to ask if there are any questions from the group, but is there something that you want to leave us with?
I'm good. Yeah. Anyone else?
Any questions?
Yeah.
When doing a solution design, what is your recommendation on what areas to simulate first?
Do you want to take that?
I love this topic. We tried to go at the simulation as a large monolith to try and solve for it. And what we very quickly realized is it's almost an impossible task just from an overall scale perspective. Because storage takes up the highest square footage, like even talking about POCs, our first POC in this arena was actually within the storage space. So we are trying to optimize for what should be the storage profile that actually tells you what is the best utilization. Let's call it 60, 65% of the facility is actually going to have that as a footprint. Everything else kind of latches on. But to have a good simulation, I would say you do, because you can't take storage in isolation to get a good output. You have to take the receipt, the outbounds, every other process into consideration as well. But if I was to start with something, it's usually the storage profile that will inform me of the processes that we are going to undertake, right? And it will inform me on the CapEx side. Am I bringing in an ASRS? Am I bringing in AMRs? Am I going to have conveyance, right? Like all of that gets informed right there from a storage perspective, which also takes into consideration the pick and the pack and everything, right? So not a simple answer, but yeah.
I'll just augment that by saying, while we do want to focus on the end-to-end, because that's where the value is, there are modular options available, right? So figuring out what is going to be the most challenging piece of the puzzle or the most costly piece of the puzzle, be it for resources or time and money, and identifying the right tool, right toolkit, and to figure that out would be the answer, my solution. Anyone else? If not, Ninad, thank you so much for your for this conversation. It was great having
It's a
you
wrap.
here. Yeah, it's
Thank
a
you.
wrap.